Welcome to my channel, Ace Your Interview for SAS and C. In this series, I am going to cover the important topics that we normally face in the interview. Today's topic is PDV. As we know, the full form of PDV is Program Data Vector. So PDV is a logical area of memory during the data stack process. We have three components in PDV. The first is input buffer, program data vector, and the third is output buffer. So basically, SAS stores the raw data in input buffer. As we know that raw data means unprocessed original data that has not been formatted or manipulated yet. It is the data exactly as it is initially received or collected from the client. So once the data has been stored in the input buffer, then PDV comes into the picture to store the variables and their values during the data stack execution. Once these both steps, the input buffer and the program data vector, has been done, the output buffer temporarily holds the processed data before sets put into the final output data set. Now the word, if you notice here, is the execution. So as we know that data stack processing in two phases. The first one is compilation and the execution. So let's understand. So this is the data flow process through PDV. If you notice, we have three variables: ID, employee name, and the department. In ID, that is a numeric variable, and employee name, these are my character variables, and the department is also character variable. So as we know that it stores the data, raw data, whatever the raw data that we receive from the client. So suppose this is the data that we receive directly from the client. We just directly stores in the input buffer. Once the input buffer stores the data, then PDV stores the variables and their values. So like ID 20, we have employee name, subname, then we have a department, finance, and underscore and underscore underscore error underscore. But if you notice that we in raw data, we have three variables. But here we have two additional variables, underscore and underscore underscore error underscore. So basically, these automatic variables that is generated by PDV. So PDV is overall, if we are going to understand that how this SAS read from the backend. So these two automatic variables are generated from the backend. So n underscore specify how many times the data step has been iterated. Underscore error underscore specify at the time of the occurrence whenever there is an error. So at the beginning of the first observation, if you notice, the value will be the 1 for n underscore and the value will be the 0 underscore error underscore. So once the PDV stores the variables and their values, then output buffer holds the temporary data before SAS puts into the final output data set. So if you look into the definition, that it stores the input data from the current iteration of the data stack. Then second, it stores the variables and their values during data step execution. Output buffer, once these steps has been finalized, it stores the output data before being written to the output data set. Now understand the next part. So if you look into this diagram, that is a data set, name, class, and marks. We have two observations, Prerna and Shivam. The class is 9 and the marks is 65 and the 90. So what does input buffer do? So basically it just holds the data as we know. So PRERNA and then 9 and the 6. And now just go back into the PDV. It stores the variables and their values. Now PDV is storing the variables and the values. But before that, it's just creating the structure. Underscore, error underscore, name, class, and marks, and the total marks. So as we know that PDV create two automatic variables, underscore and underscore error underscore. And these three variables is directly taken from the raw data. But if you notice that we have a total marks, that is the additional variable. So PDV, in this PDV, two type of variables are created. First one is the directly taken from the raw data and the second is calculated variables. So total marks is my calculated variables. So in this structure is created. And now just look into this diagram. Underscore n underscore underscore error underscore. We have a value 1. We have a value for 0 because there is no error at the beginning. Now name, class and marks. So name and class is blank because this is a character variable. Marks and total marks is a numeric variable and that is represented by period. But why it is blank? Because if we notice that it is mentioned the stored variables and their values. Yes, PDV stores variables and their values. But always remember, this is the most important interview question. PDV is created at compilation phase. In compilation phase, it is created in compilation phase. But the value will be feeding in the execution phase. So if you look into this diagram, that input buffer is created in the compilation phase and it contains the first same line as PDV is created in the compilation phase. But if you notice, the only data structure is created in the compilation phase. That means the value will be the empty in the compilation phase. That will be feed in the execution phase. So that is the interview question. Interviewer asks like input buffer and PDV is created in which phase? So your answer will be the compilation phase. I hope it is clear. As I told you that data step process in two phases, the compilation phase and execution phase. So before I just correctly go through the definition, first imagine you are giving instruction to a robot, right? So before the robot can start doing anything, it needs to understand your command, right? That exactly what happened during the compilation phase in SAS. So SAS check every line of code that we have written to make sure it makes sense and free of mistakes. It's like having a super smart proofreader for our program. So during this phase, SAS also set up something called the PDV. Think of a PDV as a workspace where SAS keeps track all the variables and data is going to work with for the data execution phase. That is the next phase after compilation phase. But here is the catch. During compilation, the PDV is like an empty desk waiting for a task. As I already explained in this, that the PDV create only structure in the compilation phase. If you notice that this is empty, no values feed, because the value will be feed in the execution. So it just created a structure in the compilation phase. So the PDV is like an empty desk waiting for a task. It's ready to work but does not have any data yet. So in summary, the compilation phase is where SAS check our code for error, set up the PDV workspace and gets everything ready for the real action in the execution phase. Now just understand through the definition. The compilation phase is the initial stage of SAS data step processing where SAS checks syntax and the structure of the program. This is the most important part, that in compilation phase, it checks the syntax and the structure of the program. It involves scanning through the program and statement to detect any error or inconsistencies. So what does role of PDV in SAS? So during compilation, SAS identify and initialize variables, allocate memory for dataset and set up the PDV. However, the PDV is not populated with the data during the compilation phase. If you notice that still it is mentioned, still it is saying that PDV is not populated with the data. It is primarily prepared for data processing in the execution phase. So basically, it's trying to say that it's only create a structure in the compilation phase and the data will be feeding in the execution phase. So what the compilation phase does? It checks the syntax error, creating descriptive information for dataset, metadata, as we know that metadata means data about data, and allocating the memory for variables and dataset. So while preparing the PDV established during compilation, it remains empty until data processing begin in the execution phase. We have to remember it that it's only create the structure in the compilation phase. The value will not be populated in the compilation phase, that will be populated in the execution phase. Now just going into the next one. Now we have a clarity of the compilation phase. Let's understand execution. So execution phase is the most important phase because it is a place where the real magic happens. It's like a pressing play on a movie, everything comes to a life. So during execution, sets get down into a business, it read data from the input sources, whether they are data set or external file, and bring them into the PDV. So PDV becomes our dynamic workspace. SAS use it to perform calculation, apply logic, transform data based on the program instructions, whatever we are given to him. The PDV stores intermediate and final result and makes sure everything is in order before we move on. So once the data is stored and ready, SAS write it to the output buffer or directly to the output data set and create a meaningful result for the analysis or reporting. So in simple words, the execution phase is where SAS brings our program to life, processing data and making calculation produce valuable outputs. Now understand through the definition as well. So execution phase is where the actual data processing, as I already explained you, how it will process based on the instructions in the SAS program. Whatever the instructions we are given in the SAS program, it will produce the output for that. It involves the reading the data, perform calculations, apply logic and generating output based on the performed logic. The calculations will be performed as you notice that the new variable will be created in the compilation phase, but the value will be feeding in the execution phase. So role in PDV. In the execution phase, the PDV is actively used to store variables and their values. As I already explained, that it stores the variables and their values as the data is processed through the data stack. It serves as a workspace where SAS manipulate and calculate data before outputting to the data set. So what is the task for the execution phase? It reading the input data from the data set or external source into the PDV, then perform calculations and transformations and put some logic using PDV variables and storing intermediate and the final result in the PDV before output to the data set. So PDV, during execution, PDV is populated with the data from input buffer, manipulated and processed, then written to the output buffer or data set. So in summary, the compilation phase set up the environment for the data processing. Environment means set the structure, including the creation of the PDV. While the execution phase actively uses to PDV to process data, perform calculations, generate output. So in the light of the foresee discussion, it is basically trying to say that whatever the data will be stored in the execution phase based on the perform logics, perform calculations based on the program logic, whatever we are given to the instructions. So PDV plays a crucial role in both phases because if the environment is not created in the compilation phase, so it is impossible to get the data in the execution phase. So both phases are important. So PDV plays a crucial role in both phases, acting as a temporary workspace for data manipulation and the processing within the SAS data stacks. I hope it is clear. Now we move on to the next part. Compilation phase. Let's understand this through the data set. Compilation phase. This is the data. Here I'm creating a new data set, the output data set. Here I'm doing the data cloning by the input data set. If you notice that total equal to price into quantity and run. So as we know that a total variable will be created, but the value will not be feeding in the compilation. The price and the quantity or the variable that is already exist in the raw data. So that means in the compilation only the total variable will be created, but the value will not be fed in the compilation. Let's understand this through the explanation. During compilation phase, SAS checks syntax and the structure of the code to ensure it follows the rules of the SAS program. As we know, there is no syntax error because everything is properly framed as per the SAS language, right? In our SAS verify the data statement, set statement, variable, assignment, run statement are correctly structured. Yes, it is correctly structured. Now jump on the second part, variable initialization. SAS identify and initialize variable used in the program. In our example, the total price and quantity are recognized as variables and their properties, type, length and format are set. Right. Total price and quantity are my variables. So PDV is set up during compilation. Although it is created at this stage, it will still remain empty until data processing begins in the execution phase. The main focus is that it remains empty during the data step processing at the compilation stage. Now jump on the next part, execution phase. Again the same code. Now the value will be feeding in this, the total, whatever the price we have in the raw data, whatever the quantity that we will mention in the raw data, it will feeding in the total. Means the calculation will be performed in the execution phase. Now read it. In the execution phase, SAS read data from the input data set into the PDV. That means we are performing a data cloning. This includes variable like price and quantity that is already exist in the raw data. Calculation in PDV. The PDV is actively used to perform calculation. In our example, the calculation total means price and quantity is executed within the PDV. So it will store the result in the total variable. Means value will be stored in this execution phase. After calculation, the process data, including total, is temporarily stored in the PDV before directly written to the output data set. As I already explained it, PDV serves as a workspace where SAS manipulates data, perform calculations and prepared output, and it holds intermediate result during data step processing. So, I hope it is clear. Now move on to the next one. So, what does PDV interaction with the code can be visualized as follows. So, in compilation phase, only the PDV setup means the data structure is created, the syntax and all. Now, the second part is execution phase. Data reading into a PDV. Whatever the data, raw data, will be reading in the PDV. Means the price and quantity, that is a part of a raw data. I already explained and it's showing as well. The calculation in PDV, the total equal to price into quantity. The third, temporary storage of process data into PDV. And the fourth, output to the output data set. So now you have a detailed understanding of PDV. Now move on to the most important part of our series, that is the interview questions related to a PDV. So interviews are not just about answering questions, but also to showcase our understanding of the key concepts. So that's why I just explain all the concepts before just directly move on to the interview question. So my first question is, what is PDV? As we know that it is a program data vector, it's a logical area of memory that is created during data step processing. And most important thing is one thing here, the SAS build a SAS data set by reading one observation at a time. So in PDV, all in SAS data step, one observation will be read at one at a time. So you have to remember this line, that one observation will be read at one at a time. Now move on to the second question. At which stage is the program data vector input buffer created in the SAS data step process? So it is created in the compilation phase. Now jump on the third question. How many types of variable does the PDV generate? As we know that PDV generate automatic variables, but the types of variable they are asking. So there are two types of variables they are generated, permanent and the temporary. In permanent, we have two variables as well, the data set and the computed variables. Because data set variables and computed variables means the data set variables that is already exist in the raw data. Computed variables are those variables that is calculated by applying logic. As I already explained you that in PDV the structure is already created. So that is also a part of a data set variables and the computed variables. So these variables is already created in the form of a structure in the compilation phase. Now let's understand the theory definition. Data set variables. As I told you that it is a part of a raw data. Those variables that are already exist in the raw data. So these are the variables that are directly read from an input data set. Data set variables retain their value from the input data set and can be used for further processing or calculation within the data set. Means whatever the values that are feeding in the raw data will be directly feeding in the data set variables. Now the computed variables. Computed variables are created within the data step using expressions or calculations, and these computed variables applying logic based on these variables, data set variables. So these variables are not present in the original data set. As I told you that this is not a part of a raw data. So these variables are not present in the original data set. original data set means the raw data, but are generated during the data step processing. How we can generate it? Based on the computations or manipulations of the existing variables, these the data set variables. Now move on to the second part, temporary variables. We have automatic and the option defined variables. Automatic variables, these variables are automatically created by SAS during the data step processing. Example, underscore n underscore error underscore. Underscore is n underscore specify how many times the data step has been iterated. I will show you by example in the next slides. Underscore error underscore notify at the time of the occurrence. Notify the errors at the time of the occurrence. Second, option defined temporary variables. This is also temporary variables like first dot, last dot, in and end variables. These variables are defined by the programmer, means the user have to define these variables using the SAS options or statement within the data step. Like first dot and last dot are the option defined variables. Now move on to the fourth part. What are the automatic variables with definition? So two automatic variables are created in PDV. Underscore n underscore, I already explained you, specify how many times the data step has been iterated. Underscore error underscore notifies the error at the time of the occurrence. I will show you by example. Now understand it through example. Let's create a data by the naming convention PDV. PDV. Here I am doing the data cloning. We have so many observations. I am putting a restrictions on that. So PS is equal to 10, then run. Now check. We have two columns, data and year, but no PDV is represented in the output data set. Okay, now check it in the log. Again, no PDV is represented in the log. And as we are using a data step, so result window will be the null. So no data will be in the result. Because PDV, as I told you that PDV basically how SAS read data from the backend. In PDV, automatic variables are a part of a temporary variables. And as we know that temporary variables never be visible directly. If we want to make it visible, we have to apply some logic. So there is an interview question 1, like how to make it visible your PDV. So we have to use a put statement along with the underscore all. Because as we know that underscore all means all the variables that is included in the raw data and the automatic variables directly come into this figure. Now just run it. And put statement, as we know that put statement always show the information in the log. So if you notice that we have the first observation Jan 49 and 112. So my value is for the first observation underscore n underscore is the 1 because it is representing the first observation. How many times the data step has been iterated. So here in the first observation it is iterated only once. And the value is 0. Error for underscore error underscore is equal to 0. Again the same 2, 3, 4 and the value will be the 0. If there is an error, the value will be the 1. Right? So always remember that underscore error underscore is also called a binary variable because the value always will be the 0 or 1. That's why it's called a binary variable. I hope it is clear. So now understand the next question. So using the data set below, create a new data set name example underscore processed. That means the naming convention for the output data set. That modifies the value of the underscore error underscore, that is the automatic variable for the third observation. If either x or y means the variable is missing for the third observation, set underscore error underscore is equal to 2, otherwise set it to 1. But as we know that underscore error underscore is a binary variable, it always represents the value in 0 or 1. So basically through this question, the interviewer is trying to test the candidate knowledge on SAS concept whether the candidate can modify the value of the underscore error underscore automatic variable or not in a SAS data set based on the specific condition. So now just check it. Now understand this. It's saying if X or Y is missing in the third observation, although it's not missing, but we have to set underscore error underscore to 2 and otherwise set it to 1. Now let's run this data first to create a data set. This is the data I am getting. And we know the third observations 4 and 5 is not missing, but let's run it. The data we have to create a naming convention is example underscore processed. Then going to rounding example if underscore is equal to 3, then do if missing in the variable name or any, if it is not either any, missing by then underscore is equal to 2, else underscore error underscore is equal to 1. We have to close this. Then run. Now just run it. Example processed. Now check in the log. X is equal to 4, Y is equal to 5, error underscore 1, and underscore n is equal to 3. So I am not getting a value, the 2. Right. But I just want to make a change in this data. Okay. Now run it. What will be the value? Now we have a missing value in the third observation. Now check the log. The value is changing, right? Although it's a binary variable, but it's still changing because of the logic that we apply for it. So underscore error underscore automatic variable is typically used to indicate whether an error occurred during the execution of a data step for a specific observation. Its values are typically 0 or 0 in case there is no error or 1 in case there is error. So basically that's why it's called a binary variable. However, you can assign any value underscore error underscore within the data step, including 2 or any other numeric values. SAS allows you to assign numeric values to underscore error underscore as per the logic and requirement within the data step. Okay, I hope it is clear. Now move on to the next part. So what is the use of underscore n underscore variable? So n specifies how many times the data step has been iterated. So the n underscore variable in the SAS is an automatic variable. Basically, it's just trying to keep the track of number of iterations on observations processed within the data step. Now, what is the default value of underscore error underscore variable? As we know the default value. So if there is an error occurred, then value will be the 1, and there is a no error, then the value is set to 0. Basically, underscore error underscore variable can take a different values to indicate different states or conditions. So how to print PDV in a SAS log? So using the put underscore all underscore in the data step, as I already show you in the program. Like suppose there is a data A. I'm hearing using a for output data set, that is a naming convention set sasl.cars put underscore all underscore. And then run. So if this statement I am using, my value will be the printed in the log showing all the underscore error underscore and underscore error underscore. Whatever the value will be printed in PDV will be printed in the log by this statement. Okay. Now just only move on the next part. At the beginning of the execution phase, what are the values of the underscore error underscore and underscore and underscore? As we know that only the data structure is created, and I already show you by the diagram as well. So underscore error underscore, in the beginning the value will be the 0 and underscore value will be the 1. So now just look into this. The value of error underscore is 0 and underscore n is 1. Reason, by default no errors have occurred yet, and underscore variable starts counting from 1 on the first observation processed in the data step. Example, the new data is the naming convention for the output data set. Here I am doing a cloning, data cloning, and again I am putting a restrictions on that. Put beginning of execution phase underscore error underscore and underscore run. So value will be the printed in the log. Now write a program to read SSL.cars dataset, but I just want to read on the fifth observations. So case of data step, we have to give a name, fifth observation for the naming convention. Again I am doing a cloning SSL.cars and just putting a one condition, as we know that I just want to read only one, so I can use in underscore n underscore is equal to 5. So if I am using if underscore n underscore is equal to 5, there will be a counter question on that in interview. Can we use where underscore n underscore is equal to 5? No, because as we know that where statement never apply on the temporary variables. It is always applied on the existing variable that is already present on the raw data set. For whatever the new variables and the temporary variables, if you want to apply conditions on that, for that we have to use the if statement. So always remember, you don't have to use where underscore n underscore is equal to 5. That will be your error. Okay. Now move on to the next part. The calculate fifth highest marks in the data step using PDV only. As we know the proc sort data, we have to sort the data by descending. So whatever the marks that we are getting, that will be in the descending order. Then we have to select by the fifth, the same if n is equal to 5, and the fifth highest marks is your variable name. Like suppose the marks is my variable name, so I can use marks. So you have to remember that the two things whenever you want to calculate the highest marks in the data step using PDV. First important thing, you have to sort a data by descending. And the second, you have to put a condition if n underscore is equal to n. Whatever the values, whatever the sequence you want in your PDV, that you have to put for that. Now, the second is specifying error message in the SAS log using the put statement. Here I am creating a new data check underscore mpg, the set SSL.cars. I am explaining you through the program. So here I am creating a specifying error message in the SAS log using the put statement. So I am using one logic like if mpg city is less than 20, then it will showing an error. Okay. Now check underscore mpg is the naming convention for my output data set. So I am using a condition if mpg underscore city less than 20, then 2 underscore error underscore is equal to 1. I am putting the error is equal to 1 for the error. Put error, then column, lower mpg found for make. Whatever the values I am getting for this mpg city less than 20, so it will be represented in the make variable. The same, whatever the values I am getting for the model variable, it will be presented in the model. The same mpg city, whatever the value I am getting in the mpg city for this particular condition, then enclose it and else underscore error is equal to 1. Now just run it. This one syntax error, because I am putting a condition as I already explained. So this is the conditions. See here mpg city less than 20, it means 70. So make is equal to Acura, model is equal to MVS, and then here it is again 80. So that means we have a fourth mpg city that is less than 20. So that's why just representing an error. I hope it is clear now. Now move on to the next part. So retain statement is a compile statement or execution time statement. So retain statement in SAS is a part of a compilation phase. It is used to initialize and retain the value of a variable across iteration of the data step. Okay. Now the next question is how to create a serial number in a data step dynamically only. Let explain through the code. So I am creating a serial number by PDV. So data a set sl dot class, then serial number equal to n underscore run. Now run it. We have a 6 columns. Now check it. I am getting the serial number 1, 2, 3, 4, 5, 6. Total rows we have 19. So that means the 19 sequence is already generated in the serial number. So basically in dataset A, it adds a variable called serial number using the assignment statement equal to for that. Because we are creating a new variable for that. So I am using equal to sign for creating a new variable and using the automatic variable underscore n underscore. So which automatically increments by 1 for each observations read from the data set. So this serial number variable effectively assign a unique serial value like to each observations in a new data set starting from 1 and increasing by 1 for each subsequent observation. I hope that is clear. Now move on to the next question. So what does it mean if underscore n underscore is equal to 20 and underscore error underscore is equal to 1? It implies that an error occurred during the processes of the 20th observation within the data set. Now the next question is calculate cumulative sum, means the running total for a single variable by using automatic variables PDV for the below data set. So this is my data set. So I am getting the 10 in the first observation, second, 20 and 30. I just want to calculate the cumulative sum. Like first observation it will be 10, for next it will be 30 and for the next last observation it will be 60. How can we calculate it? So we have to use a series and retain statement for that. Let me explain you through the program. So now we have a data, 3 lines, input value 10, 20, 30 and run. So let's run this data set first. So we have a value variable 10, 20, 30 and the observations is 3. Now I'm creating a new data set, that is A, by the naming convention for the output data set A. The set 3 lines, we are doing the data cloning and series equal to underscore n underscore. Here I'm creating a serial number by using automatic variable underscore n underscore. Here I am using a retain statement. So retain statement is used to retain the value of a variable. So in this code, cumulative is scored across iteration of the data step. When n is 1, that means the first observation, the value of value is assigned to a cumulative score. So whatever the value is for the first observation is assigned to the cumulative score. So here I am getting the value for the first observation is 10. It will assign to the cumulative score. And for the subsequent observations, the cumulative score is updated by adding the value to the value to it. That means the 10, 20, then the second observation will be the 30, then the third observation will be the 60 for the cumulative scores. And here I am using a drop statement to drop this series because I don't need in my output data set the serial number. So now just run it and check the output. Here I am getting the serial number at 10, 30 and 60. But if you notice, here I am using a single variable. Now, the question will arise for the multiple variables. So now, move on to the next question. Now, move on to the last question. So, calculate the cumulative sum or running total for multiple variables. That means the growth. Here we have to do a small change here. Now, we are using for the multiple variables. For that, we have to use only small function, sum function for that. Sum function and then the list of variables that we want as cumulative sum, var1, var2, var3, then rest everything will be the same like as we calculated for a single variable. If you notice, and again I am using a drop option to drop the serial number. I hope it is clear. So thank you so much for watching this video. I hope now you have a better understanding of the PDV. Don't forget to subscribe and give it a thumbs up if you found this content helpful. And if you have any question or need further clarification, please feel free to leave them in the comment section below. Thank you.